Hello and welcome to In Simple Terms with Satish. Today, let's understand how NASA gets pictures back from Mars. Start with one photo. A rover is sitting on Mars looking at rocks, dust, and a red horizon. Its camera captures light and turns that scene into pixels. Later, we see that image on Earth and it feels simple, but that photo did not travel like an Instagram upload. There is no Wi-Fi on Mars. There is no cell tower next to the rover. There is no router floating between planets. The picture has to become data, then a signal, then a faint whisper moving across space. Inside the rover, the camera data is compressed and packaged into bits. Those bits are not useful until they ride on something physical. So the spacecraft transmitter changes a radio wave in a controlled pattern. That process is called modulation. The changing radio wave carries the bits. Then an antenna sends the wave outward. Sometimes a spacecraft can talk directly to Earth, but Mars rovers often use a smarter route. They send data up to an orbiter around Mars, and the orbiter forwards it towards Earth using a stronger link. That is the first big lesson. Space communication is not one magic beam. It is a planned chain of links. The next problem is aiming. Power is precious on a spacecraft. You cannot waste energy shouting equally in every direction. Many spacecraft use high-gain antennas which work like narrow flashlights for radio energy. Point the antenna well and more of the signal reaches Earth. Point it badly and the data rate can collapse. Now the signal has to cross distance. Radio waves travel at the speed of light, but Mars is far enough that light speed still feels slow. NASA says one-way delay between Earth and Mars can be about 4 to 24 minutes depending on where the planets are. That means nobody is driving a Mars rover with a live joystick. NASA sends instructions, the rover executes them, and the results come back later. Space communication is patient by design. On Earth, the main catcher for deep space signals is NASA's Deep Space Network. It uses giant radio antennas in California, Spain, and Australia. Those locations matter because Earth rotates. When Mars drops below the horizon for one site, another site can keep listening. The largest dishes are about 70 meters across. That size matters because a deep space signal arrives incredibly weak. By the time the wave reaches Earth, it is not a loud voice. It is closer to a whisper crossing the solar system. So engineers balance spacecraft power, antenna size, frequency, weather, bandwidth, mission priority, and ground station schedule. The rover cannot send unlimited high-definition video whenever it wants. It chooses, compresses, schedules, and transmits what matters. Near Earth, NASA uses a different but related system called the Near Space Network. It supports missions within about 1.25 million miles using ground stations, commercial assets, and relay satellites. Different distance, same pattern. Moving spacecraft, planned links, and ground systems listening at the right time. Then comes reliability. Space signals can be weakened or corrupted by distance, atmosphere, the sun, weather, and noise. So receivers do not blindly trust every bit. They use error detection and error correction to check the message, repair what they can, and recover useful data. That is how a photo survives the trip without turning into random speckles. NASA is also developing optical or laser communication. Infrared light can carry more data than many radio links, but lasers need precise pointing and can be affected by clouds and turbulence. So radio remains the workhorse while optical links are the high-capacity future. The useful mental model is this. NASA does not just connect to Mars. It operates a delay-aware communication pipeline. Pixels become bits, bits ride radio waves, antennas aim the signal, orbiters may relay it, giant dishes catch it, software repairs it, mission control turns it back into a picture. So the next time you see a Mars photo, remember, it is not only space science. It is networking under brutal constraints. Distance, delay, motion, power, pointing, and noise. That picture is a message from another world that found its way home. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish and share this episode with one friend who likes technology. I will see you in the next episode.